now we are going to start with a new topic from the S block element only, that is hydrogen. Actually, we call hydrogen, or rather in an old periodic table, hydrogen was kept in a group 1. But later on, when we are studying its properties, it was found that the position of hydrogen is uncertain. Now, what is the reason behind it? Because of the electronic configuration and the various properties, hydrogen behave like a group 1 element. But at the same time, it can also behave as a group 17 elements. So, what are those things, what are those properties which we have to study so that the hydrogen, the position of hydrogen is uncertain? So, let us consider resemblance of hydrogen with alkali metals. So, if we consider its electronic configuration, that is 1s1. And if I consider the electronic configuration of lithium or sodium or potassium, so the general electronic configuration is 1s2, 2s1. So, that is for lithium. For alkali metals, the valential electronic configuration is ns1. Since one electron is entering in s orbital, they are called as the s block element, and hence hydrogen is also called as s block element. Then it is highly electropositive. It can lose electron so that it gives you a proton, same as that of the alkali metals. They are also losing one electron, giving you cation, positively charged ion. It can react with electronegative elements and form compounds like this way. For example, if we consider hydrogen react with oxygen, giving you H2O, then H2S, then we can say H3PO4 and so on. Same kind of a compounds are formed when alkali metals react with these elements. For example, M2O, then we have M2S, then we have M3PO4 and so on. Interestingly, H2O, we have H2O2 also. Same way here also we have M2O2 also, except lithium. Hydrogen is a good reducing agent. So, zinc oxide when react with hydrogen gives you Zn plus H2O. So, hydrogen can act as a good reducing agent. Hydrogen form when react with halogens. So, H2 when react with halogens, it actually gives you what? Hydrogen halide. Same compound, similar kind of a compounds are obtained when alkali metals react with halogens, that is metal halide. Due to all these reasons, hydrogen is showing similar properties to that of the S block elements, rather alkali metals. Now, as we have seen, there is a resemblance of alkali metals with the hydrogen. Now, we will see hydrogen with halogens. So, again the same thing, the electronic configuration. So if I consider the electronic configuration of hydrogen, one electron is present in a valence shell. So to complete its duplet, it accepts one electron. Same thing for halogens. To complete their octet, they accept one electron. Okay. Next one. Hydrogen is electronegative. The electronegativity of hydrogen is very high as compared to the alkali metals, and it is somewhat close to that of the halogens. Therefore, hydrogen is a non-metal, same as that of the halogens. It is a good oxidizing agent also, or it can act as oxidizing agent. Okay, so Na plus H2 gives you NaH. The oxidation of sodium is taking place because of hydrogen. It can react with metals and form metal hydrides. Reacts with metal, forming metal hydrides, which have a similar characteristic, similar structure to that of the halides of metal. Okay, so as we can say MHX, here also we can say about MXN. So here the X stand for halogen, here the X stand for valency of this metal. So these are similar properties of hydrogen. Because of this, hydrogen, the position of hydrogen is now uncertain. At the same time, some of the properties of hydrogen are not similar to that of the alkali metals also. For example, alkali metals are metals, hydrogen is a non-metal. Alkali metal act as only reducing agent, while hydrogen may act as an oxidizing agent. Alkali metals cannot combine with metals, but hydrogen can combine with metals. So there are so many such properties which distinguish hydrogen from alkali metals. So if you see in a modern periodic table, the position of hydrogen is somewhere at the center, at the top of the periodic table. Okay. So this is the introduction part of a hydrogen. So free hydrogen is not available in nature because it is highly reactive. It is always found in the form of compound, and a very famous compound of hydrogen is water. So guys, now we are going to discuss the isotopes of hydrogen. This table depicts the various isotopes of hydrogen. Three isotopes of hydrogen are there: hydrogen, which is also called as a protium, deuterium and tritium. In a protium, there are no neutrons. So if we consider hydrogen, then deuterium and tritium is like this way. So Z in this case 1, 1, 1. So mass number here is 1, 2 and 3, and therefore neutron number 0, 1, 2. This way we can calculate the number of neutrons. So this table actually depicts that three isotopes of hydrogen. In nature, the abundance of protium is almost 99%. Deuterium is hardly 1%, 1 point something, and tritium is very small, about 10 raised to minus 15%. And this table also depicts that hydrogen and deuterium are stable, they are non-radioactive. Well, tritium is radioactive, its half-life period approximately 12 years. Now, when we are dealing with the isotopes, their nuclear properties are different, but their chemical properties are same. In case of isotopes of hydrogen, also the same thing. All these three isotopes react in a similar way, but the rate of reaction depends upon the mass. So, it was observed that the protium is more reactive than deuterium because of the mass. This is called as the isotopic effect. So, this is all about the isotopes of hydrogen. Now, we are going to discuss the dihydrogen part, that is H2. Hydrogen is a very important gas which is used in old days. It was used in a balloon because it's a very lightest gas actually, but it catch fire immediately, highly inflammable, and the inflammation and that inflammability and that it catch fire with the explosion. Therefore, nowadays instead of hydrogen, helium gas is used, but hydrogen is mainly used as a fuel in a fuel cell as well as in a welding. So, what are the different methods of preparations of hydrogen? Hydrogen mainly prepared from active metals like sodium, potassium, calcium, etc. These metals reacts with normal water, cold water, giving you corresponding hydroxides and hydrogen gas is liberated. While metals like magnesium, aluminium reacts with hot water and liberates hydrogen gas. While metals like Fe, nickel, Sn reacts with water, but it is in a gaseous way, steam. So, steam is passed over these metals so that the corresponding oxides, metal oxides are obtained and the hydrogen gas is liberated. Beside the reaction with water and liberation of hydrogen gas, there are certain metals which reacts with acids as well as alkalis. For example, magnesium, aluminium react with dilute acid like HCl so that hydrogen gas is liberated and the corresponding salts are obtained. These reactions are taking place under normal conditions. Fe, then Ni also react with HCl, but here we have to heat it, and in that case the hydrogen gas is liberated. Compounds like zinc, beryllium, which are actually amphoteric, so they also react with HCl, giving you hydrogen gas and the corresponding salt. But compounds like elements like zinc, beryllium also react with NaOH, giving you hydrogen gas and the sodium salt of this zinc and beryllium. Even the aluminium is also react because aluminium also act as a amphoteric. So, these are certain laboratory methods of preparation. Commercially, hydrogen is prepared by syngas Bosch method and Lenz process. In a syngas Bosch process, steam is passed over a red hot carbon. Steam is passed over red hot carbon. So, the temperature is something around greater than 1000 Kelvin, so that we are getting a water gas. water gas is the major source of hydrogen. Water gas is the major source of hydrogen. And the another commercial process, and that is Lens process. In a Lens process, iron, red hot iron and steam are used. So it is a similar reaction which we have done here, but here actually the compound which is obtained, that is minus Fe2O3, ferric oxide, can be reduced again, and after reduction we are again getting Fe and we can produce hydrogen gas from that Fe. So these are the preparations of hydrogen. Now we will go for the reactions of hydrogen. Hydrogen is highly reactive, but the dihydrogen is less reactive than the atomic hydrogen and the nascent hydrogen. Now, what is the basic difference between these three? Dihydrogen is H2, that means whenever the reaction is taking place, that HH bond has to break. Since HH bond, the size of the hydrogen atom is very small, we required huge amount of energy to break this, and therefore dihydrogen is the least reactive as compared to the nascent hydrogen and atomic hydrogen. After breaking HH bond, we are getting hydrogen atoms, and that is called the atomic hydrogen, which is highly reactive species. So the most reactive species in these three is the atomic hydrogen. Now, during certain chemical reactions, for example, zinc when react with HCl, zinc when react with ethanol, sodium amalgam when react with H2O, the hydrogen is liberated. Now that hydrogen actually evolved in the reaction C2, which is not actually atomic hydrogen, but it is one of the most reactive hydrogen part, that is called the nascent hydrogen. Now if that nascent hydrogen come across with some other reacting species, then it will get combined. But if it won't get any reactive species, then the two nascent hydrogen combine to give you dihydrogen gas. So the nascent hydrogen only exists in the reaction C2. Their existence is sometimes considered as a hypothetical. So we are dealing with the reactivity of dihydrogen. So it reacts with almost metal as well as non-metals. So it reacts with oxygen. Under normal condition, there is no reaction between hydrogen and oxygen because the bond dissociation energy required is very high. So here we require a temperature of about 970 Kelvin, and there is the formation of H2O. It reacts with halogen, and there is the formation of hydrogen halide. The order of reactivity of halogen is fluorine is greater than chlorine is greater than bromine is greater than iodine. Fluorine has a high affinity for hydrogen. Even the direct combination of hydrogen and fluorine at normal condition is a very exothermic and explosive reaction. Therefore, to get hydrogen fluoride from hydrogen, the reaction is taking place in a dark and at a very low temperature. Same way, the reaction between hydrogen and chlorine in a sunlight is an explosive reaction. As we move down, the reactivity goes on decreasing. The reaction between hydrogen and iodine is reversible because Hi is a strong reducing agent. Okay. Hydrogen can combine with metals, active metals like sodium or calcium or potassium, alkali metals or alkaline earth metals, gives you metal hydride. This N stands for the valency of metal. So there may be a formation of ionic as well as ionic hydrides, covalent hydrides or the molecular hydrides. We are going to discuss that next one. Hydrogen is a strong reducing agent. So it reduces zinc oxide, so that we are getting zinc metal. It reduces lead oxide, so that we are getting lead plus H2O. It reduces ferric oxide, so that we are getting Fe and H2O. Therefore, in the metallurgy, to get a metal, we are using hydrogen as a reducing agent. It also combined with carbon at a very high temperature greater than 1000 Kelvin, so that we are getting methane hydrocarbons. It can combine with a nitrogen, so the reaction is reversible. By using Haber's process, we can prepare ammonia. Hydrogen when react with unsaturated hydrocarbon like alkene, so we'll start with alkyne first. So it react with alkyne, first it gives you alkene, which further react with hydrogen gives you alkane. So unsaturated hydrocarbon can be converted into saturated hydrocarbon by using hydrogen. Similarly, hydrogen when react with vegetable oils, edible oils, will get vanaspati ghee. Okay, the solid form of a fat. So these are some important reactions of hydrogen along with the methods of preparations of hydrogen.